This shape broke mathematics. It's called Gabriel's horn, and it starts with the most innocent curve in all of math, y equals 1 over x. Take this curve and spin it around the axis. You get an infinitely long trumpet. And here's where reality falls apart. Ask a simple question. How much paint fits inside this horn? Calculus gives a clean answer. Exactly pi. About 3 liters. Finite. Now ask, how much paint would it take to cover its surface? The math says, infinite. No amount of paint in the universe is enough. Think about what that means. You can fill this shape with paint, but you can never paint it. Mathematicians have argued about this for 400 years, and the resolution will change how you see infinity itself. The year is 1643. Calculus doesn't exist yet. Newton won't even be born for another few months. In Italy, a mathematician named Evangelista Torricelli, a student of the great Galileo, is playing with a dangerous new idea, slicing shapes into infinitely many pieces. He applies it to this trumpet and finds something that terrifies him. A shape that is infinitely long, yet holds a finite amount of space. When he published it, the intellectual world went into shock. The philosopher Thomas Hobbes reportedly declared that to accept this result, a man didn't need logic. He needed to be mad. But Torricelli's math was airtight. The madness was real. To understand how Torricelli pulled this off, decades before calculus, you need to meet his secret weapon. His teacher's other student, Bonaventura Cavalieri, had proposed something scandalous. Treat every solid shape as a stack of infinitely thin slices. Indivisibles, he called them. The old guard hated it. Infinity was not a tool. It was a sin against rigor. Respectable geometry came from Euclid, in finite steps. But Torricelli didn't ask for permission. He took the forbidden method and aimed it at the impossible trumpet. Slice by slice, the infinite horn surrendered a finite answer. The method worked, before anyone could explain why it was allowed to. Let's see what Torricelli saw. Slice the horn into thin discs, like a loaf of bread. Each disc is a circle. Its radius is 1 over x, so its area is pi over x squared. Watch what happens as we move down the horn. The discs shrink. Fast. Brutally fast. By the time x reaches 10, the disc holds just 1% of the first disc's area. At 100, 1/10,000th. Add up infinitely many of these discs, and the total doesn't explode. It converges. It settles on exactly pi. An infinite number of pieces, a finite total. That's the first miracle. Before we touch the surface, you need to see the oldest infinity in mathematics, because it's the exact engine behind what happens next. Take the series, 1 plus a half plus a third plus a quarter, forever. Each piece gets smaller. Surely the total settles down. In the 1350s, 3 centuries before Newton, a French monk named Nicole Oresme found the devastating truth. Group the terms, a half, then 2 terms that add to more than a half, then 4 terms, then 8. Infinitely many groups, each worth at least 1/2. The sum grows forever. This is the harmonic series. Pieces that shrink to nothing, and still, the total is infinite. Keep it in mind. It's about to ambush us. So why doesn't the surface behave the same way? The surface is made of rings, not disks, and a ring's size depends on its circumference, 2 pi over x. Here's the trap. 1 over x shrinks much, much slower than 1 over x squared. Slow enough that when you add the rings up, the sum never settles. It grows, forever, past any number you can name. Think about how razor-thin that boundary is. 1 over x squared, finite. 1 over x, infinite. A single power of x is the difference between 3 liters of paint and all the paint in the universe. Now the paradox has teeth. Fill the horn with pi liters of paint. Every point of the inner surface is now touching paint. But we just proved that surface is infinite. And infinite surface should need infinite paint. So the same act is both possible and impossible. 3 liters of paint appears to coat an infinite surface. Something, somewhere, has to give. The first crack in the paradox. We never defined what paint is. Real paint is made of molecules. Travel far enough down the horn, and the throat becomes narrower than a single molecule. Real paint physically cannot go deeper. The filling was never truly complete. Mathematical paint, the ideal kind, has no molecules. It can be spread infinitely thin. And there it is. The paradox doesn't live inside the mathematics. It lives in the gap between mathematics and the words we use to describe it. But here's the beautiful part, the resolution most people never hear. When you fill the horn, the paint does touch every point of that infinite inner surface. Finite paint, infinite surface. How? Because the coat of paint gets thinner as the horn gets narrower. Thinner and thinner, without limit. An infinite area, multiplied by a vanishing thickness, can equal a finite volume. That's not a trick. That's the actual mechanism. Infinity isn't defeated here. It's tamed, balanced perfectly against zero. And if you're wondering just how sharp this knife edge really is, let's play with it. We built the horn from 1 over x. What if we used 1 over x to the power 1.001? Barely different, invisibly different. The surface becomes finite. The paradox evaporates. Go the other way, 1 over the square root of x, and now even the volume explodes to infinity. No paint could ever fill it. 1 over x isn't just a curve. It is the exact boundary between the finite and the infinite, the knife's edge of the universe. Gabriel's horn lives precisely on the line. And once you see this trick, infinite surface squeezed into finite space, you start finding it everywhere. The Koch snowflake, a curve with an infinitely long edge, wrapped around a finite area. Coastlines, measure with a smaller ruler, and the length keeps growing. And the masterpiece, your own lungs. Roughly 70 square meters of surface, a tennis court, folded into a few liters of chest. Because that's how you extract oxygen. Maximum surface, minimum volume. Evolution discovered Gabriel's horn 3 billion years before Torricelli. Torricelli glimpsed all of this in 1643, 30 years before calculus even had a name. His horn taught us that infinity is not a number, it's a direction. And whether the journey ends depends entirely on how fast you shrink along the way. 1 over x squared, the journey ends. 1 over x, it never does. The universe doesn't fear infinity, it builds with it. Every frame of this video was drawn by code, mathematics rendering itself. If this changed how you see infinity, subscribe. There are more shapes that broke mathematics, and we're going to meet all of them.